Okay, this kind of problem is relatively easy. The question is, if you're given the atomic weight and the atomic number of an element, you should be able to prove the number of protons, neutrons, and electrons. All right, well, by now I would really hope that you know what the atomic number means. The atomic number is the number of protons, okay? So that means boron, which is atomic number 5, must have 5 electrons. All right? I'm sorry, 5 protons. All right, that being said, usually it says it's a neutral atom, all right? So if you're dealing with a neutral atom, if you have 5 protons, which are positive, that means you must have the same number of electrons, therefore you have 5 electrons, all right? The positive charges balance out the negative charges. Problem with neutrons is neutrons don't have any charge, so they don't automatically equal the number of protons, but they do add weight. All right, so what do we know? Well, we know the atomic number of boron is 5, and its atomic mass is 10.811. Now, hopefully you remember the problem in that, the reason that is because there are different isotopes. Some types of boron have maybe more neutrons and some have less. So the way you can figure out the number of neutrons in the most common isotope, which is what I'm asking you here, pretty simple. All right, what you do, take the atomic mass, which is 10.811. You subtract the atomic number, all right, because protons and neutrons equal together what equal the atomic weight of the atom. And when you do that, we wind up with a mass of 5.8. All right, and since that means what that probably means is that most boron atoms have 6 neutrons. All right, but there are a few that have 5, and so basically there are 2 isotopes. Some have 6, some have 5, but the majority have 6 neutrons, and that's how we answer that question. All right, 5 protons, 5 electrons, 6 neutrons, and that's the same. It works the same way for all the other guys. Just remember, atomic number equals the number of protons and electrons. The atomic mass, or the atomic mass minus the atomic number, is going to come close to, but not exactly, the number of neutrons in the most common element. All right, and that's how you come up with that.